Molecules and reactions. Elements that have an incomplete valence shell are very reactive. But what does that mean? When atoms react with one or more atoms, they join together. A set of joined atoms is a molecule. A molecule can be made of the same kind of atoms, making it an element, or it can be made up of different kinds of atoms, making it a compound. A compound often has very different properties from the element that made it. For example, pure water is a compound. It is made of hydrogen and oxygen. When two hydrogen atoms and one oxygen atom come together with enough energy, they combine to form a water molecule. Hydrogen and oxygen are both colorless gases at room temperature. But as you know, water is a liquid at room temperature. Oxygen won't turn to liquid until it reaches a chilly minus 219 degrees Celsius, or negative 362 degrees Fahrenheit, and hydrogen at negative 259 degrees Celsius, or negative 434 degrees Fahrenheit. Imagine if it were cold enough to have liquid oxygen raining out of the sky. Very unstable. Some elements are so reactive that they are not found in their pure states in nature. Just how reactive are we talking here? Sodium is very reactive. It will react with oxygen in the air. Sodium also reacts with water, and if the temperature is right, it can actually catch fire. There are millions of compounds known today, and more are always being discovered. Not all atoms can react with one another, though. It all comes down, once again, to the arrangement of their electron shells. Super scientists. Marie Curie was a Polish scientist who studied matter. She and her husband Pierre discovered two elements, radium and polonium. Pierre and Marie won a Nobel Prize in Physics in 1903. In 1911, Marie won a second Nobel Prize. Only 4 people have won this prize twice. All compounds are molecules, but not all molecules are compounds. Types of bonds. In order for 2 or more atoms to bond or join together, they must physically meet. They also need to be compatible. This means they must have the right properties to create a reaction. In addition, they need energy to form the bond. If these requirements are not met, then no reaction will occur. Atoms want to be as stable as possible. Unstable atoms usually bond in an attempt to complete their valence shells. There are different ways that 2 or more atoms can bond. One way is through a covalent bond. Covalent bonds form when 2 of the same or similar atoms share electrons between them. To do this, they join valence shells. A covalent bond is usually formed between 2 nonmetals. Doubling up. Atoms can create a double bond. A double bond is when 2 atoms bond with each other twice. When both atoms are missing 2 electrons, they can fill each of those missing spots and create 2 bonds. Carbon is the most common element to form this type of bond. Some elements, such as hydrogen, will form covalent bonds with themselves. They do this if there are no other elements to react with. These elements are called diatomic. Diatomic means 2 atoms, diatom. These atoms are naturally found in sets of 2. Hydrogen, oxygen, fluorine, and chlorine are all examples of diatomic elements. Hydrogen is the most common naturally occurring diatomic molecule in the universe. No fair. Atoms don't always play nice. If atoms have different charges, then they might share their electrons unequally. One atom might hog the electron. Oxygen tends to hog electrons. It is a negative, giving it a negative charge. When hydrogen bonds with oxygen, the positive and negative charges attract, forming water. Shared electrons. Doot, doot, doot. Another kind of bond is an ionic bond. An ionic bond forms between different types of atoms. In fact, ionic bonds usually form between metals and nonmetals. An ionic bond is formed when one or more atoms take electrons from another atom to fill their valence shells. This creates charged ions because the numbers of electrons and protons in each atom do not match. For example, sodium has 1 electron in its valence shell. Chlorine has 7 electrons in its valence shell. The sodium wants to give up an electron, and the chlorine wants to gain one to fill its outer shell. So the electron from sodium jumps over and fills chlorine's shell. Now the sodium has a positive charge because it has more protons than electrons. And chlorine now has a negative charge because it has more electrons than protons. These two atoms are called ions because they have a charge. Since opposites attract, the ions come together and form an ionic bond. This forms a new molecule called sodium chloride, also known as table salt. Ordinary table salt. Pure sodium is a silvery metal that is soft enough to cut with your ruler. But don't get it wet. It pops and fizzes when it touches water. Chlorine is poisonous gas, but put them together and you have table salt, sodium. Sodium reacts with water. Metals versus nonmetals. Metals and nonmetals have many differences. Metals. 1 to 3 valence electrons. Nonmetals, 4 to 8 valence electrons. Metals lose valence electrons easily. Nonmetals gain or share valence electrons easily. Metals are good conductors. Nonmetals are poor conductors. Metals are metallic, shiny. Nonmetals are dull, transparent. Metals are dense. Nonmetals are low density. Metals usually solid at room temperature. Nonmetals are solid, liquid, or gas at room temperature. Metals melt at high temperatures. Nonmetals melt at low temperatures. Metals easily bend into shapes. Nonmetals cannot change shape easily. Example for a metal would be silver, gold, platinum, potassium. And nonmetals would be hydrogen, carbon, nitrogen, oxygen. Periodic table of elements. The periodic table of elements is a chart that organizes elements based on their properties. It can be very useful in understanding the relationships between different elements. The table is arranged in rows and columns. The rows are called periods. This is where the periodic table gets its name. The columns are called groups. The elements in each period are arranged by size. The elements in each group are sorted by property. Each element is represented as a labeled square. Typically, at least 3 things are present. Each box will show the element's atomic number, how many protons it has, a name, and chemical symbol. Most tables also use colors to show groups of elements that have something in common. All metals may be one color or texture. All nonmetals may be another. For instance, on this chart, the elements are sorted by color. The squares may also include a number that describes the mass or weight of the element. Chemists use this information to figure out how substances will react. The periodic table organizes all the known elements. The specifics. To better explain how this works, let's look at just one element, potassium. Potassium is a soft, silvery white metal. Like pure sodium, it can be cut with a ruler or butter knife. Potassium is number 19 on the periodic table. This is also its atomic number. So we know that potassium has 19 protons in its nucleus. Its atomic weight is 39. This means that 1 atom of potassium weighs 39 atomic units. You might notice that the weight listed below is not exactly 39. This is because some potassium atoms are slightly heavier. Potassium's chemical symbol is K. This may not look like it should stand for potassium, but it's because potassium's Latin name, kalium, begins with the letter K. Potassium is in the fourth period of the periodic table, which means that it has 4 electron shells. It is also in the first group of the periodic table, which means that it is extremely reactive. In fact, it explodes when it touches water. Because of this, pure potassium is not found in nature, but it is found in many different compounds. Some potassium compounds are found in foods, such as bananas, and are very good for your body. So we have the atomic number, the symbol, the name, and the atomic mass. Potassium reacts with water. Tables and tables of elements. The standard periodic table is just one of many arrangements that people have come up with over the years. There are some arranged in spirals or circles. There are even 3-dimensional models. The standard table is used most because it is simple. Periodic divide. Noble gases. Interesting. Transition metals. Lanthanides. Creator of the table. Dmitry Mendeleev created the Dmitry Mendeleev, I'm not too far off, created the periodic table we use today. He put elements in rows and columns by their atomic weight. But his genius idea was to leave gaps in the table. He predicted where undiscovered elements might be in the table. He guessed their properties based on their positions. Later, scientists proved his predictions were correct. Not just bubbling beakers. Sometimes people like to say that food or products are bad because they have chemicals in them. But chemistry is the study of matter and how it interacts, so chemicals are anything and everything that's made of matter. In short, everything is made of chemicals. It's true, some chemicals can be harmful, but if you understand their properties, you can know how to interact with them safely. By studying matter and how it acts, we can make predictions about the world. We know what will happen if certain things are mixed together. We can also make changes to the world. Many of the products that exist today are a result of people studying matter. Chemists have learned how to make medicine that help treat diseases, and they have learned how to make plastics that are strong and light enough to build space shuttles. By learning more about matter that surrounds us, we can find new ways to solve many problems. People live longer today because of our knowledge about elements and how they react. This helps chemists make medicine that saves lives. Accidental discovery. Artificial sweeteners were discovered by accident in 1879. Konstantin Fallberg had been in his lab trying to make new food preservatives. He forgot to wash his hands, and one of the chemicals remained on his skin. At dinner that evening, he noticed that his dinner roll tasted sweeter than usual. Luckily, the chemical didn't kill him. Instead, he made an exciting discovery. Think like a scientist. How can you create a chemical reaction? Experiment and find out. What to get? Half a cup hydrogen peroxide, half a cup of warm water, 1 packet of dry yeast, 1 tablespoon of liquid dish soap, clean plastic water bottle, food coloring, funnel, safety goggles, and a tray. Ooh, this sounds very familiar. What to do? 1. Put on the safety goggles, dissolve 1 packet of dry yeast in a warm water and set it aside. So I'm not going to read the rest of this. We did this in class a few times. So here's your glossary and your turn. Matter is everywhere. Search your home for matter. Find 10 household items. Make a chart by listing each item. Organize the list based on properties. What kind of material is each item made of? What is its purpose? Why does it work? What else can you observe? And you don't have to do that for our class, but you can do that for fun. We'll see you on Thursday.